Chapter 2, we're going to discuss motion. This chapter in particular is really important. Lots of concepts that are useful for teaching in the elementary school level. So it's going to have lots of concepts, lots of examples, some formulas, and some units. So in this chapter, we're going to describe motion. We'll talk about measuring motion, speed, velocity, acceleration, forces, 3 types of motion: horizontal, vertical, and compound. Laws of motion: mass and weight. Momentum, conservation of momentum. Impulse, circular motion, law of gravitation, and weightlessness. So to start off describing motion, motion is one of the most common events in your surroundings, hence why it's going to be something that's going to be usually taught at the elementary school level, because motion is something that's very familiar and relatable to children. There are 2 important aspects of motion. One is that there's a change in position. So if we see here the ballet dancer from point A to point B, she is leaping, and we can see that she travels a certain distance. And the second aspect is a passage of time. So it took time for her to leap up in the air and then land on the other side. And those are the 2 aspects of motion that we are going to measure. There are 3 ways we can combine distance and time. We have speed, which is something you might be familiar with because your speedometer tells you how fast you're going. Velocity, which if you've ever seen Despicable Me, you know that this is a vector, and we'll talk about why velocity and vector, the image here, are related. And then acceleration. If you've ever ridden a roller coaster, you know that as you go up, you slow down, and then as you go down, you speed up, and that is acceleration. So speed is a measure of how fast you are moving. We have 3 different kinds we can describe. Constant speed is when you're moving equal distance over equal periods of time. So if you did something like put your cruise control on and you're traveling at a consistent speed, that would be constant speed, and it's traveling equal distances over equal periods of time. Average speed is more or less what we are probably typically measuring. It's the amount of distance traveled over a period of time. So realistically, when you go on a road trip, you are not going to travel 60 miles an hour the entire time. You are going to slow down, speed up, and so average speed takes into account those increases and decreases in speed. The third is called instantaneous speed, and it's the speed you're going at a specific moment of time. And this is what we measure with the speedometer. When you look at the speedometer, you are measuring your instantaneous speed, not your constant or average, but instantaneous speed. Now speed is going to be, there's a formula. So we have speed is equal to distance over time. The units could be miles per hour, feet per second. So these are both English units. And you could have kilometers per hour, meters per second, and these are SI units. So a wide variety of speed units. Really what it depends on is the distance. Are we measuring long distances, short distances, long distance, short distances? Are we talking about a long period of time, a short period of time? Now, average speed is calculated very similar to this. So say that you go on a road trip and you travel 50 kilometers in the first hour, another 50 kilometers in the second hour, and another 50 kilometers in the third hour. So in total, you're going to travel 150 kilometers, and the elapsed time is going to be 3 hours. But you want to know what the average speed was between the first hour and the third hour. Well, you ended at 150 kilometers. You started at 50 kilometers when you started the clock. So we're going to subtract 150 and 50 to tell us the amount of distance traveled. And you're going to divide that by the elapsed time, which is 3 minus 1, to give us 2 hours. So we get 100 and we divide that by 2, which gives us an average speed of 50 kilometers per hour. So velocity. Velocity is going to describe speed, which is how fast am I going, and so important, direction. Where am I going? So we use what's called a graphical representation a vector, which is why this image is here. A vector is really another word for an arrow. But the arrow is going to be descriptive in two ways. The length of the arrow, whether it's short or long, is going to tell us how much. We use that term magnitude to mean how much. So the bigger the number, the bigger the arrow. The smaller the number, the smaller the arrow. Now the arrowhead is going to indicate direction, whether it's up, down, to the upper right-hand corner, the lower left-hand corner. Okay, so that's going to tell us direction. So here's some examples. In this instance right here, A and B, the car is traveling 30 miles or 30 kilometers per hour east, so traveling to Shreveport from Marshall. In the second one, the car is still going east, but the car is going twice as fast. It's going 60 kilometers per hour. So while their speed is different, their direction is the same. In this case, we have a car that's going 60 kilometers per hour. So it's going the same speed as car B. However, it's going in a northwesterly direction, so going up towards like Sulphur Springs for Marshall or Gilmer instead of going east, and therefore it's going a different direction, and the arrow represents that. You can see here that the arrow on car A is half the size of B and C because it's going half the speed. Acceleration is the rate at which motion changes over time. And there's three ways that we can describe acceleration. The first is that the speed changes. The second is that the direction can change. And the third is going to be that both the speed and the direction will change. So we're talking about the final velocity minus initial divided by the amount of time that velocity change occurs. So say this person is in a race right here, this first one. And we say ready, set, go, and then they take off and they start running. And we can see that they're speeding up. Well, that's acceleration. It's the same thing when you're sitting at a red light, the light turns green, you hit the accelerator, and you start speeding up. In B, we have a skateboarder who's going very, very fast, and then they eventually slow down and come to a stop. And even though they're slowing down, it's still acceleration because their speed is changing. Now, sometimes we call this deceleration, which means to slow down, but it's still an acceleration. In the last one, we have a bee here who is going up and over, making circular, buzzing around. And in this case, the bee is changing acceleration because the bee is changing direction. In A and B, the person traveling is always going from left to right. But in the case of C, the vector is changing, right? So remember we had those arrows, and in this case, the arrows are changing. The bee is not going constantly left to right. Sometimes the bee is going to the upper right hand, the lower right hand, going upper left hand. And so this is also a change in acceleration. And then you could also have both, a combination of speeding up, slowing down, and changing direction. So make sure you understand that acceleration is not just the act of going faster, but it's slowing down and it's changing direction. So this is going to end the first part of our video, and you'll come back